This class is very important. If you understand these terms, what is heat capacity, specific heat capacity, molar heat capacity, change in internal energy and change in enthalpy, if you understand these terms, then only you are going to understand what is adiabatic process and what is the isothermal process and the terms involved in it, right? So observe this class carefully, then the isothermal process and adiabatic process, it will be very easy for you, right? First, we are going to discuss about the heat capacity. What is heat capacity? The heat required to raise the temperature of a substance by 1 degree centigrade. Suppose this is the substance. So how much heat is required? Suppose this is the pen. This temperature is assumed that 35 degrees centigrade. This is the pen. This temperature is 35 degrees centigrade. So the heat needed to raise its temperature by 1 degree centigrade. That means 35 to 36. The heat needed to raise the temperature of the substance by 1 degree centigrade is called heat capacity, right? So what are the terms here involving? Heat is involving, temperature is involving. What is the symbol for heat? Q. What is the symbol for heat? Q. What is the symbol for temperature? T. Symbol for temperature? T. So the heat capacity formula involves the terms Q1T, right? So heat capacity symbol is C. Heat capacity symbol is C. So it involves the two terms. What are the two terms? Q1T, right? So we will write here Q by, right? dQ by dt, right? dQ by dt, right? We will write like this. So C equal to dQ by dt. So the temperature required to increase the heat required to raise the temperature of the substance by 1 degree centigrade is called, right? By 1 degree centigrade is called heat capacity, right? So coming to here, specific heat capacity and molar heat capacity. Very simple. So for specific heat capacity, write the formula as it is. First write the formula as it is, right? Write the formula as it is. In place of before dm, just place m. Before dm, just place m, that is specific heat capacity. Write the formula as it is. Before dt, just place m, right? I am writing clearly m, that is specific heat capacity. Then write the formula as it is. C equal to dQ by dt. C equal to dQ by dt. Just place n before dt. Just place n before dt. This is called molar heat capacity, right? So comparatively, if you study, so I am not mentioning anything. I am not mentioning grams or moles. I am just talking the heat required. The heat is needed to raise the temperature of the substance by 1 degree centigrade or 1 Kelvin is called heat capacity. It is 1 degree centigrade or 1 Kelvin. So coming to the specific heat capacity, observe carefully. So I am mentioning the grams. I am mentioning specific heat capacity. I am mentioning the 1 gram, right? So that heat required to raise the temperature of the 1 gram of the substance. So here we are not mentioning 1 gram. Here we are not, for heat capacity we are not mentioning 1 gram. But specific heat capacity we are mentioning 1 gram, right? So the heat required to raise the temperature of the substance by 1 gram is called specific heat capacity, right? So if 1 gram it is specific heat capacity. For 1 gram, for m grams we will take, right? So for m grams we will take. This pen weight is not 1 gram, right? This pen is not 1 gram. It may be 4 grams or 5 grams. If you take other substance, that may weigh 8 grams or 10 grams, right? It won't be a 1 gram always. That's why we take m here. That's why we put m in denominator over here. That's why the formula comes C equal to dQ by m dt. Now coming to the molar heat capacity, observe carefully. The heat required to raise the temperature of the substance, 1 mole of substance. The heat required to raise the temperature of the substance by 1 degree centigrade or 1 Kelvin of 1 mole of substance, right? Here we are not mentioning anything. Here we are mentioning the heat required to raise the temperature of 1 gram of substance by 1 Kelvin, 1 degree centigrade or 1 Kelvin. Here we are talking the heat required to raise the temperature of 1 mole of substance by 1 degree centigrade or 1 Kelvin is called molar heat capacity. I think you understood very clear. So this is, don't mention grams or moles, just give the statement the heat required to raise the temperature by 1 degree centigrade or 1 Kelvin is called heat capacity. If you want a specific heat capacity, specific heat capacity, the heat required to raise the temperature of the 1 gram of substance by 1 degree centigrade or 1 Kelvin is called specific heat capacity. Well, coming to the molar heat capacity, the heat required to raise the 1 mole of substance by 1 degree centigrade or 1 Kelvin is called molar heat capacity. Now coming to the CV, just here in place of denominator m come for specific heat capacity, for molar heat capacity n will come. For CV, what you will write, just first write the formula. C equal to dq by dt. C equal to dq by dt. First write the formula. Suppose in examiner in question if he mentions molar heat capacity at constant volume, right? First write this. So CV is nothing but molar heat capacity at constant volume. The CV equal to molar heat capacity at constant volume. CV equal to molar heat capacity at constant volume. So molar heat capacity means here n will come. So how we will write here? C equal to dq by ndt. Why am I putting here? CV is molar heat capacity at constant volume. That's why molar means n need to come. So C equal to dq by ndt. So we are mentioning at constant volume we are mentioning molar heat capacity at constant volume mentioning. So we will take this V. We can mention V over here. First write the formula as this. Molar heat capacity they are mentioning mole means n. That's why I am putting n over here. QV I am putting because they are mentioning molar heat capacity at constant volume. So this dQV we can write as delta U. So molar the change in heat at constant volume, the change of heat at constant volume is called delta U, change in internal energy, right? The change in energy at constant volume is called change in internal energy. This dQV we can write as du. So if you rearrange the equation, so delta U equal to n CV n CMV delta T, right? N. So I rub and neatly write over here CV by n dt. Okay. If you rearrange the equation and write delta U equal to n CVM into delta T, right? This is the equation. I repeat. Write the equation, the heat capacity equation. CV means nothing but the molar heat capacity at constant volume. So molar means n should come here, right? So at constant volume we are doing, that's why dq I have written as dqv. dqv is nothing but the change in internal energy. So heat change at constant volume is nothing but change in internal energy. If I rearrange this equation, so delta U equal to NCVM delta T. CVM is nothing but molar heat capacity at constant volume. Suffix we need to mention. Suffix we need to write here. Suffix we need to write here. CVM is nothing but the molar heat capacity at constant volume. Now Cp you can write, right? If you write for Cp, Cp is nothing but the molar heat capacity at constant pressure. Cp is nothing but molar heat capacity at constant pressure. If you write here, first write is C equal to dq by dt. First write this, right? So Cp is nothing but the molar heat capacity at constant pressure. So we will put dq by n dt over here, right? So here in place of dq we will put dqp. Why? Because the change in heat at constant pressure. So the change in heat at constant pressure is nothing but the delta H. The change in heat at constant pressure is nothing but the change in enthalpy. Right? If you rearrange the equation, we can write delta H equal to n CPM into delta T. Delta H equal to n CPM into delta T. Okay. So now you know how CV has come and how CP has come. So molar heat capacity at constant volume, molar heat capacity at constant pressure, delta H equal to n CPM delta T. These formulas we are going to use in adiabatic process and isothermal process. These formulas we are going to use, I am going to use while explaining the isothermal and adiabatic process. Kindly understand how these formulas are coming. Okay, now relation between the Cp and Cv. So I will explain next. First, just now I am writing, right? Cp minus Cv equal to R. Cp minus Cv equal to R. Cp by Cv equal to gamma. How this will come? What is gamma? I will explain. Now I don't want to complicate this. For now, remember Cp minus Cv equal to R. The relation between Cp and Cv equal to Cp minus Cv equal to R. Cp by Cv equal to gamma. I think you are clear till here, right? So C equal to dq by dt. For specific means grams will come. That's why C equal to dq by m dt. Just we are putting m over here. Molar heat capacity. Just we are putting m over here, right? So if molar heat capacity at constant volume, right? In place of C we are putting Cv. dqv is nothing but the delta U. So delta U equal to NCVM delta T. If you take Cp, right? Molar heat capacity at constant pressure, right? So we will put Cp here. In place of dqp we will put here. dqp is nothing but the delta H. Delta H equal to NCP delta T. Next relation is Cp minus Cv equal to R. Cp by Cv equal to gamma. How this will come, I will explain you, right? Now understand, see the relation Cp minus Cv equal to R, Cp by Cv equal to gamma. What is delta U here? Delta U already you have derived here. Write that directly. Delta equal to NCVM delta T, right? So delta H directly right here. Delta H equal to NCPM delta T. So delta equal to the change in energy at constant volume. Delta H equal to at constant pressure, right? At constant pressure. Now relation between the delta U and delta H, we have the relation, right? Delta H equal to delta U into delta PV. This is the very important relation, right? This is very important relation. You need to remember it. Delta H equal to delta U into delta PV. This is the relation between delta U and delta H, right? So I will go in depth. So this video I am just explaining the terms, right? In isothermal process, while we are going to do for studying isothermal and adiabatic process, I will go in depth. Right now I am giving the glance what is what. Okay. Now if you take for delta H equal to delta U plus P delta V, right? So here we have delta PV. If P is constant means, we use to write the equation delta H equal to delta is P delta V. Understand carefully. So this is the equation. If examiner mentions P is constant means take the P out and write P delta V. If an examiner mentions V constant means how you are going to write this? So delta H equal to delta U plus V delta P. So if examiner mentions V is constant, how you are going to write? Delta H equal to delta U plus V delta P. Next, for an ideal gas, N1 moles to N2 moles it will come. So suppose if you take an ideal gas, if its volume is changing, so we are going to apply this equation. This is the equation. This is the relation between the delta U and delta H. We are going to apply this equation for an ideal gas. If the examiner gives the question delta H and delta U, which relation to the ideal gas, then you need to how you are going to use this formula, that we will derive now, right? First write the formula delta H equal to delta U plus delta PV. So here they are mentioning it is an ideal gas. You know ideal gas equation, that is PV equal to nRT. But what they are mentioning, there is a change in the moles from N2 minus N1. So there is a change from the moles from N1 to N2. So I will slightly write this equation delta PV equal to delta NNG into RT. So this equation is at constant pressure and temperature. So at constant pressure and temperature, R is constant and T is constant. So I am not going to apply delta for them. R is constant, universal constant. In question he will mention T is constant. So I am going to apply the delta for moles over here. So PV equal to nRT. So if we write the ideal gas equation and apply the delta over here, delta PV equal to delta Ng RT. I am going to directly apply over here. So delta H equal to delta U plus delta Ng RT. Right? If they have given the ideal gas, we have to apply this formula. So this formula is very very important. Definitely one question will come. The relation between the delta H and delta U. So regarding ideal gas, it will come. He will give the moles of the gas, change in the moles of the gas, right? And he will ask you to calculate the delta H. He will give delta H value. He will give delta U value, delta H value. He will give delta U value. He will give the constant temperature value. He will give, right? And R value, you know, universal gas constant. From based on that, he asked us to calculate. From based on that, we need to calculate the what is asked in the question from examiner. Okay, so I will brief you and I am going to stop this video. So heat capacity, right? So the heat required to raise the temperature of the substance by 1 degree centigrade. So specific heat capacity, the heat required to change the temperature of the substance, 1 gram of substance by 1 degree centigrade or Kelvin. Molar heat capacity, the heat required to change the temperature of the 1 mole of substance by 1 degree centigrade or 1 Kelvin. So what is the units? And if you calculate the units, if you write the units, right? So for heat, joule, right? For temperature, degree centigrade will come. Here if you write joule, here for taking one mass, telling gram, right? 1 so gram, degree centigrade will come. If you write units here, joule for mole, degree centigrade will come. Okay. Now you know molar heat capacity at constant volume equal to NCB delta T. Molar heat capacity at constant pressure delta H equal to NCP delta T. The relation Cp minus Cv equal to R, Cp by Cv equal to gamma, and here the relation equal to delta H equal to delta U plus P delta V, right? So if pressure constant, we will write delta H equal to delta U plus P delta V. If V constant, we will write delta H equal to delta U plus V delta P, right? For an ideal gas changing from N1 to N2, we will write delta H equal to delta U plus delta EV, and finally rearrange delta H equal to delta U plus delta Ng